Hello everyone, today we will discuss AC to DC converter. It is a topic in power electronic subject. So it is very important topic with respect to gate. AC to DC converters are also known as rectifiers. It is a static power electronic circuit that converts input AC to output DC. There are basically three types of rectifiers: uncontrolled rectifiers, in which the output, we cannot control the output, and fully controlled rectifiers, in which we can fully control the output, and half controlled rectifiers, which is also known as semi converters. In uncontrolled rectifier, there are basically two categories. Number one is single phase control uncontrolled rectifiers, and three phase uncontrolled rectifiers. In single phase uncontrolled rectifier, we have half wave and we have full wave. In three phase also, we have half wave and we have full wave. In half wave, we have different types of loads like R load, RL load, RLE load, pure inductance, pure capacitance. So we have different types of load which we have to study. So without any further ado, let's start with single phase half wave uncontrolled rectifier with R load. So the very first step is, whenever we get question related with this single phase half wave uncontrolled rectifier with R load or anything like that, the basic mindset is that we should proceed with the steps. So first step is draw the diagram. As the name suggests, it is uncontrolled rectifier, means the switching device which is used in this circuit is nothing but a diode, as you can see from the diagram. Switching device used here is diode. Diode is basically uncontrolled device. Why? Because in diode we cannot control the output voltage of diode, because in diode, if anode voltage is more positive than cathode voltage, if anode voltage is 9.7, cathode voltage is 9.69, if it happens, then diode will conduct. We can't do anything. Diode will conduct, conduction will start, current will flow in the circuit. So it is dependent, like it is not controllable. Whenever the supply voltage is more positive, or whenever the anode potential is more positive than cathode potential, the diode will conduct. So it is uncontrolled. That's why in this diagram we are using diode, which is acting as a uncontrolled switch. Not acting, it is an uncontrolled switch. And with R load, as you can see at load side, resistance is connected and the supply voltage, which is single phase. So this is what the first step. Now second step is to draw the waveform. To draw the waveform, first draw the waveform of supply voltage. So just you have, the second step is to draw the waveform of supply voltage. Just ignore these things. We have to only, step one is we have to only draw the waveform of supply voltage. So this is nothing but single phase supply. Vs is equal to Vm sin omega t. Okay. Now second step is to analyze, or mathematical analysis. As we can see from the supply voltage waveform, from 0 to pi, Vs is positive. And as I've already said, that whenever diode sees that, okay, its anode voltage is more positive than cathode voltage, then the diode will conduct. And from 0 to pi, we can see from the waveform that Vs is positive. If Vs is positive, this means positive terminal of the supply voltage is connected to the anode and negative terminal is connected to the cathode. Or we can say directly that if anode is more positive than cathode, that's it, diode will conduct. If diode will conduct, as we are assuming in all the rectifiers, converters, inverters, we will assume that all our power electronic devices is ideal, that is their on state voltage drop is 0 and their forward leakage current during off state is 0. So we are considering it, or all power electronic devices, we are considering it as ideal. So as you can see from VD waveform, VD means voltage across the diode. Through waveform you can see that from 0 to pi, as diode is in on state, there is no on state voltage drop, so voltage drop across diode is 0. And also as diode is in conduction, as there is no on state voltage drop, so we can replace diode with short circuit. As you can see from this diagram, we can replace diode with a short circuit, as we can see from this diagram. So easily current can flow through it. If current is flowing through the resistor, then what is the voltage across the resistor? Voltage across the resistor, that is nothing but the output voltage only. So output voltage across the resistor is I naught into R. And also we can apply KVL to the loop. If we apply KVL to the loop, you can see that this, as VD is equal to 0, on state voltage drop across the diode is 0, because we have assumed the diode as ideal diode. So from here we can see that supply voltage is equal to the load voltage. So whatever the supply voltage waveform from 0 to pi, the same waveform we will get in the case of load voltage also from 0 to pi. From 0 to pi, the supply voltage waveform is equal to load voltage waveform. We have seen from this equation also, we have done mathematical analysis also. So now next, from during pi to 2 pi, now here, during pi to 2 pi, as we can see that as now supply voltage is negative, now the diode, now the anode side of the diode is negative as compared to the cathode side of the diode, means anode potential of the diode it is negative as compared to the cathode potential of the diode. So therefore diode will not conduct. As we are considering ideal diode, no current will flow. This means we can replace it with open circuit. We can from pi to 2 pi we can replace it with open circuit, because diode will not conduct. Why it will not conduct? Because anode potential is less than the cathode potential. Anode potential is negative and cathode potential is positive. And as diode is an uncontrolled device, it will not conduct. And as it is an ideal diode, we can replace diode with open circuit. So from pi to 2 pi, we can see as if no current is flowing through the circuit, because it is an open circuit. Current only flows in the closed path, as no current is flowing in the circuit. So therefore the load voltage will be 0. We will not get any output voltage. So therefore from pi to 2 pi waveform is like this of load voltage. Okay, and from pi to 2 pi, if we apply KVL inside the loop, suppose if we apply KVL inside the loop, so it is minus Vs minus Vd minus V naught. As V naught is 0, because I naught is 0, I naught is equal to Is is equal to Id. The supply current, the diode current, the load current, all are same, because it is a series network. Okay, so from this equation we can say that by applying KVL in this loop, we can say that voltage across diode is nothing but negative of supply voltage. It is not like that take negative of supply voltage again and it is positive. No, it is negative side of the supply voltage only. So this is the waveform. So we can see as voltage across diode is nothing but Vm. As voltage across diode is nothing but Vm from pi to 2 pi. Now this is what the step 3, that is mathematical analysis. I am repeating once again. Step 1 is to draw the diagram. Step 2 is to draw the waveform of the supply voltage. Step 3 is to analyze and as well as also draw the waveform side by side. And step 4 is the calculation. That is calculation of V naught average, I naught average, V naught RMS, I naught RMS. As we know that how to calculate the average of anything and RMS of anything. So how to calculate average voltage? So the average of anything can be calculated. Suppose if we have 10 boxes, okay, or 10 numbers or anything, any numbers, okay, and if we have to calculate the average, what we will do, we will just sum those all 10 numbers and we will divide by 10. In the same way, in the power electronics subject also, we will take average, we will take integration, because we can't take sum, so we will take integration, because it is continuous, it is not discrete. So we will take integration to sum it up and we will divide by the time period of the waveform. So that's what we are doing. So to find out the V naught average, what we will do, we will take time period of 2 pi. Time period of, I hope you all know what is the time period of this waveform. Time period of this waveform is 2 pi. So we will take V naught average. Every average quantities is represented with capital letters and every instantaneous values is represented with small letters. So V naught average is equal to 1 upon 2 pi from 0 to 2 pi V naught, that is small V naught. You can see here, I'm sorry. V naught average is equal to 1 upon 2 pi. Actually, we have to take from 0 to 2 pi, but the V naught waveform is only available from 0 to pi. As you can see from the diagram, it is only available from 0 to pi. From pi to 2 pi, V naught is 0. So it is unnecessary, it is a waste of time. So 1 upon 2 pi, 0 to pi, small v naught is equal to Vm sin omega t, because from 0 to pi, V naught is same as Vs, which is nothing but Vm sin omega t. Now after taking the integration, we can get V naught average as Vm by pi. Vm is nothing but peak value of the supply voltage. Vm is nothing but peak value of the supply voltage. So and I naught average is equal to V naught average by R. Why we are doing this? Because the load is resistance. As you can see from this waveform also, that I naught and V naught are in phase with each other. Why? Because this is a resistive load. Resistive load means in phase element. Resistive element is nothing but in phase element, that is voltages and current are in phase. So therefore I naught average is equal to V naught average by R, because it is a resistive load. Similarly, we have to calculate RMS value of output voltage. How to calculate RMS values of output voltage? RMS values of output voltage is like root mean square. Means first take square of that where we have to for which we have to find out the RMS value. First take square of V naught and then take its mean and then take its root. So root mean squared value. So from here you can see, from here we can get V naught RMS as Vm by 2. From here we can get V naught RMS as Vm by 2. You can solve it. And I naught RMS, as it is a resistive load, so I naught RMS is nothing but V naught RMS divided by R. Now there are various conclusions. If you don't want to remember this derivations and waveforms and everything, so you can just understand in just one go and you can just learn these conclusions. These conclusions are very important. So we have to, first conclusion is V naught average. V naught average is nothing but Vm by pi, where Vm is nothing but the peak value of the sinusoidal input supply. Vm is nothing but peak value of sinusoidal input supply. If in question, if examiner has given like supply voltage is equal to 10 sine omega t, find out the average voltage. So how average average voltage. So how we can find out? We can find out 10 divided by pi. RMS voltage is 10 divided by 2, because Vm is nothing but the peak voltage of the sinusoidal input supply. Okay, diode is on only when supply voltage is positive. That is very much clear to us. P naught average, that is average power consumed by the load. Average power consumed by the load is V naught RMS into I naught RMS. Now, you can say that why we are taking RMS values, we can take average values also. But whenever we are talking about the resistance, the resistance will consume the RMS power. Like whenever we are talking about resistance, we have to relate with RMS concept only. And whenever we are talking about that how much power is consumed by the battery, we have to talk about the average values only. So here we are talking about that how much power is consumed by the resistance. So we will talk about the RMS values only. So this is what the RMS values. So P naught average is equal to V naught RMS into I naught RMS, or we can also write it as I naught RMS whole square into R. I naught RMS we have to calculate with the derivation. V naught RMS we have to calculate with it with derivation, and I naught RMS is nothing but V naught RMS by R. So R on is the resistance of the load. What is the R on? R on is the resistance of the load, not R on, it is just R. It is my mistake, I'm sorry. This is R. This is only R. R is nothing but the resistance of the load. Now, what is the conduction angle of the diode? As you can see from the waveform, the diode is only in conduction from 0 to pi, and again it is in conduction from 2 pi to 3 pi. So from here we can say that diode is only in conduction from till 0 to pi, that is pi minus 0 is pi. This is what conduction angle of the diode. If we have to find out the conduction time of the diode, we have to divide by omega, because the axis, you can see that axis is in omega t. It will give us the only angle. If we have to find out the conduction time of the diode, we have to divide it by omega. And peak inverse voltage, that how much voltage diode can block during its off state, that is known as peak inverse voltage. How much voltage diode can block during its off state, it is known as peak inverse voltage. We have to never identify or mark it as negative voltage. No, because inverse is already mentioned by the examiner. So peak inverse voltage, it is the voltage, it is the magnitude basically, that how much magnitude diode can block it. So this is the thing. Hope you all like it.